Hey everybody, welcome back to another exciting edition of Hacking JavaScript. Uh, Today we're going to be talking about a cool cross-site scripting challenge that was recently making its way across social media. It was another challenge from a company called BugPOC in combination with sponsorship from Amazon. And you can find this challenge here at wacky.buggywebsite.com. What I've done is to put most of the solution into a GitHub repo so that those of you who want to kind of just sink your teeth right in can go and spin up some of the local resources without having to maybe flounder a bit trying to get some of the local setup that you'll need to solve this challenge. But the first thing we'll do is just kind of jump right into the code and see what's going on here. So the purpose of this particular challenge is to alert the purpose of this challenge is to alert the document origin using some sort of cross-site scripting approach. However, there is a necessity to bypass the content security policy that is in this document. So we're going to take a look at the CSP first and then dive into some of the code, and we'll get a sense for how we want to go about attacking this particular application. So the first thing I'm going to do is open up one of my Chrome extensions, the CSP Evaluator. It's a great Chrome extension. It's free. And what I like about it is kind of what it makes very, very clear at first glance here that of the various things included in the content security policy for this website, we'll notice that the only thing that is missing and has some sort of high severity finding is the fact that there is no validation for a base URI. So that's something that we're going to take a very close look at here in just a minute, but we can definitely see that a script source, it's using this number once function as well as enforcing a strict dynamic property here on the CSP. The frame can only come from domains that are of the same domain, and it doesn't allow us to inject any objects. So we're not really going to be able to do a whole lot with creative script injection or frame injection, things like that. We are going to have to find a way to utilize this missing base URI approach. So the first thing I always do when I'm looking at a challenge like this is simply right-click and look at the source code for the particular application. And right off the bat, we're not going to see a ton here in the index HTML. I mean, we are going to notice that there is a link to a sub page called frame HTML in which it is passing some sort of parameter. So the fact that there is parameter passing is definitely a red flag to me as a security tester that I'm going to hone in on that as a potential vector for cross-site scripting. We can see that there's a separate HTML file for sponsor HTML, and there is actually a script file that gets included here on the page. So let's take a look at the script file first, and what we'll see is that we are being forced to use Chrome for this particular cross-site scripting challenge. If it's not detected as Chrome, it'll give you some other message. So you definitely have to use Chrome, and I do believe the terms of this particular challenge were also to use the latest version of Chrome. So if we're stuck using Chrome, we'll just move on here. We'll notice that there's an event handler for onKeyUp on this element called txt. And if we just jump back real quickly to the source code and we look for txt in here, we notice that there's a text area. It's an ID of txt. So anytime you key up inside of that text area, it is going to replace any of the following characters according to this regular expression. So we cannot use an ampersand, an asterisk, the open or close tags, or even the percentage characters. They will all get replaced with an empty string. And in fact, if we came over here and we simply tried to type in script, or perhaps even if I were to type the word script, copy that and paste it here into the box, the second my finger leaves the keys, you'll see it immediately strips those out. So that's going to hinder us a little bit in creating this cross-site scripting attack. And then last but not least, when you click the element button, it's going to grab the value out of that text box, and it's going to append that to the iframe's source attribute. And we're going to create a link to frame HTML param, and again, adding the value onto there. So just double checking what we've got down here. The iframe, it's named iframe with the iframe as the ID. So this is where that param is going to get injected here. So that definitely looks promising for an injection vector, but as I mentioned, because it's stripping out everything in here, typing something directly into the box probably isn't the way we're going to be able to attack this challenge. So backing out of this, if we go into frame HTML, what we'll notice is that when we try to view the frame outside of an iframe, we get this error page. So let's take a look at the source code for frame HTML. And what we'll notice is that we do include some scripts, and again they have this number once hash, which is going to give us problems a little bit later on in this challenge. We skip through some of the CSS that's applied, and we get down to another inline script where it's going to do a variety of things, namely creating some random colors around the text that gets rendered to the screen here. So those items, if you sit and look through the code in this challenge long enough, what we'll find is that it's going to take the text that is given to us, and it's going to loop through every character in that, adding a span tag around the each one of the characters in that text. And to kind of drill this home, if I right-click and inspect element on some of these items here, what we'll see is that there is in fact a span wrapping the H in hello, or span wrapping the E, the L, the O. So long story short, even though it is this piece of JavaScript injecting what we've typed into the box here and passed via the get parameter into the frame, that unfortunately it's going to end up rendering that with a series of spans around each character, which again really limits what we're going to be able to do for a cross-site scripting challenge. As we continue looking through the inline scripts, we'll notice at the very bottom we're doing a file integrity check, giving some sort of SHA-256 value for what will be included, assuming that we load this application inside the iframe. Then it's going to add that integrity value as an attribute on an inline script creation. So what basically happens is when the application is loaded in an iframe, it's then going to load up this files analytics.js, frame analytics.js file, which we'll take a look at here in a second. And if it's not inside the iframe, then it replaces everything in our inner HTML with the error message that we see right here. Last but not least, if we take a look at the file, or sorry, the frame analytics file, we don't really see anything useful here. We see a couple of console logs, which really don't do much for us. So long story short, this is going to be a challenging thing for us to inject a script tag into, because we have to bypass a lot of elements of the content security policy, as well as bypassing something to do with file integrity. So a lot of this is going to come into play here in a little bit. The first thing I want to do, though, is try to see if we can't bypass the problem with the iframe, because if we want to be able to follow on with the theory that the website we're looking at, the frame that we're looking at takes a parameter that presumably could be anything. Like potentially this could be a script tag with an alert, maybe alert 42, something like this. If the theory is that we should be able to do that, then the first thing we have to do is bypass the problem with the iframe. So what we're going to do is do a little bit of JavaScript magic to allow us to very quickly bypass this problem. And what we're going to do is to take a look at some code that I have here in my Git repo that I have running locally on my local computer. So what I have is an Express.js server. I have enabled cores because that will be important here in a little bit, but just know that this application doesn't really do much. It enables cores for cross-origin requests, and it's just using a couple of static resources that I have in my public folder, specifically an index.html, as well as a frame analytics file, which we'll come back to here in a little bit. The index.html literally doesn't do anything inside of the body except inject a script. But this is an important thing for us because when we look at the validation code in here, it's saying if window.name == iframe. Now, what we did notice a moment ago was that if we look at the content security policy, frame source is set to self, which means that in order to use this inside of an iframe, we have to be on the same origin as the domain for that frame HTML. So if we're going to be using frame HTML, then the iframe pointing to that file also has to be on wacky.buggywebsite.com. So I can't just shove an iframe on my local host and have this work. Something else we could do would be to physically tell the window object what its name is, and then just redirect our page. And that's exactly what we're going to do here with these two lines of code, where we're simply going to say window.name is equal to iframe. And then we're going to redirect the URL back to frame HTML so we can begin playing with it. And I have this running on port 3001. So what I'll do is open up localhost and go to 3001. And what we'll see is that it immediately redirected me to wacky.buggywebsite.com/frame HTML. And we no longer have that error message, which is pretty good. So I'm going to quickly open up my JavaScript console, and you can see some of those console logs that came out of frame analytics.js. So step one of bypassing the check for the iframe is now complete. Now we can begin to play with some of the theories that we had about the parameter being injectable. And if we do something like put the word test, we'll see it's going to inject the word test there. But if you've got an eagle eye, what you might have noticed is that the title of my web page also changed to test. And maybe put another couple of characters in there. we'll see not only does it update what gets rendered to the screen, also changes what's in my title tag. So although, if you recall a moment ago, I mentioned that all of these characters are being wrapped in span tags, which really neuters any attempt we have at injecting something there. The question becomes, well, can we escape the title tag? And that would be kind of the first area for me to look at. So I might do something like title, and then try to do some sort of script where we try to alert a value and hit enter. And well, it does try to do something down here, but obviously all these are wrapped in span tags. But now is where we start to run into the content security policy. So it refuses to execute my inline script because it violates the CSP, specifically that script source where, number one, I'm not following the number once value. So every script that we include here, even though it's an inline script, has to have this dynamically rendered nonce value. And it's going to be the same for every value here on the page. And that has to match what's coming from the content security policy itself, which if we look at the HTTP headers, the response headers, what we're going to see, content security policy, it has a nonce with a, in this case it's a WRMY value, but if I refresh the page, we're going to see this gets changed on every page load. So now it starts with QLVEL. And if we look at the page source again, we'll see QLVEL. If I refresh the page, we'll see it change every single time I refresh the page. So that's going to be a problem for us to bypass. Now, if we reconsider what we talked about at the beginning, this base URI, what exactly is the base URI? You might be asking yourself. This isn't an HTML tag you typically see every day. But if you look at the MDN docs for the base tag, and we pull that up, what we'll notice is that the base element specifies a base URL to use for all relative URLs in a document. So what that means, coming back to the source code, is that any file that's loaded via a relative URL could be you could point to a file of the same name and same path just on a different domain if you have the ability to do that. And what we should notice is that we do have a relative URL for the source attribute way down here in this section of the code. So what we might attempt to do, keeping in mind that I have my local host running on port 3001, what we might want to do is, instead of trying to put a direct script injection here in the top of our HTML document, we could try to do a base tag and give it a source value of http://localhost 3001. And what we'll see is that, if I flip over to my console, actually nothing is different here. I bet you my base tag syntax is incorrect. Oh, it's href, not source. So changing this to href. Now, what we can actually see is that here in our network tab, Frame Analytics.js, which was formerly being loaded on the same domain as WackyBuggyWebsite.com, is now being served off of my local host. And we do have a problem here, is that it failed to pass an integrity check. So we'll come back to that in a second. The important thing to note is that on my local host, I do have a files analytics.js folder inside of which we have a little bit of code, namely a console log and an alert. So the question becomes, how do we bypass the problem with integrity? And if we go back to the original source code, see window.fileIntegrity. So this is another bit of DOM clobbering that we're going to have to do in order to bypass what's happening. Because window file integrity is being set to either the value that already exists or some new object. The question is, how can we set this value somewhere else in our injection so that we utilize that value and not something else? Well, in my HTML code, something that I've done is to give myself a little shortcut to say what we need to do first and foremost is to come up with the correct sub-resource integrity hash of my local file. So the hash we see here is the hash of the file that's on wacky.buggywebsite.com. I need the hash on my local file. And if you follow the link I have here on GitHub to Mr. Goron's solution to this challenge, first of all, he does an excellent job writing up all of the individual steps for this challenge. So I highly encourage you to read this. But if we scroll down a bit and find the section where he talks about generating that SRI, we get is a Linux command using OpenSSL to create a SHA-256 hash of our local file. So I've already done that, and I stored that here. And the way we're going to go about clobbering the DOM to bypass the check on window file integrity is to think about some HTML elements, when they are assigned an ID, just appear as global values on the window object. And we can do that using an input, where you give in an input with the name of file integrity, perhaps an input that has a value, and that value is equal to the hash of my local file. If we were to add this to the attack we already have going up here, I just pop this on the end, what we're going to find is that we should be able to bypass that integrity check. And it's possible I have mistyped something, so let me copy my entire value once again. And paste that here. And it doesn't actually like that integrity value. Let me try this one more time here. So let's where'd it go? There it is. So let's go open my terminal, and let's go into public files analytics.js, and instead of jQuery.js, what we want to do is look at the name of this is Frame Analytics.js. And it will give me a hash, and that looks probably different than what I actually had there before. So let me fix that here in my local code. And I actually missed the S at the beginning. So now let's see if the hash I've used here actually works. So that did in fact work. So a note to anybody watching this, you may have to regenerate that hash when you pull down the Git repo. We'll see a console logs hacker, which is exactly what I had told it to do here in Frame Analytics. However, it is not actually working with the alert, and it's saying the document is sandboxed and the allow modals keyword is not set. Now, going back to Mr. Goron's write-up, what we'll actually find is that, let's see, we'll scroll down quite a bit, escaping the iframe sandbox. He talks about how we have to dynamically create a script include. In order to do that, we need to go through the existing nonce values that are in the document in order for us to do this. I did not add all of this to my Git repo, but I would encourage you to pull down my code and then play with what Mr. Goron has here on his Medium post, because it goes a long way to explaining how you can pull those nonce values out at runtime, and then how you can construct the proper script include so that you can include that analytics.js alert, append that to the body, and then it will successfully alert a document.domain and pass this challenge. So hopefully you've enjoyed this very speedy walkthrough of the BugPOC Wacky XSS challenge. And if you have any questions, comments, things you'd like to see in the next episode of Hacking JavaScript, I'd love to see it. So smash that like button, click subscribe, and hopefully we will see you again soon. Thanks for watching, everybody.